Welcome, everybody, and thank you for joining us today for the launch of our Practical AI event series. My name is John Lazar, and I'm the president of the Royal Academy of Engineering, and it's truly a great pleasure to be hosting this series of online fireside chats where I speak to AI innovators and adopters to get under the skin of what it takes to responsibly integrate AI into everyday infrastructure and services to improve people's lives. I think, as many of you know, earlier this year, the government launched the AI Opportunities Action Plan, which is a strategic roadmap designed to accelerate AI adoption, enhance infrastructure, and support talent development. But we know that AI adoption can be really challenging. It requires an understanding of the problem you're trying to solve, the right data and technologies, and a collaborative effort that builds trust. Our Practical AI series aims to share stories about where this has worked well, to support our audience to navigate some of the common challenges. I think it's worth saying that with all of the AI hype, it's very tempting to think of the current movement with AI as just being a digital intervention. But as all engineers know, this is a complex systems problem. And as we begin to knit and plumb AI into what many people think of as the boring stuff, but which of course engineers think is interesting, that's infrastructure, particularly critical infrastructure, complex systems, that's a painstaking process that needs to be handled really, really carefully. It's also tempting to think of generative AI, which is obviously the recent hype, as being the only AI. But of course, there are so many other AI techniques and strands which can be used for different problems. Also worth saying that with growing discourse about the risk that the AI bubble could burst due to organizations experiencing limited return on investments in generative AI, we want to focus on examples where AI has delivered measurably better outcomes. And that's why I'm really delighted we're going to hear about the experience of developing and deploying VivaCity's near-miss AI detection in the West Midlands to improve road safety. While official government statistics show a general downward trend in the number of people killed on roads in Great Britain, we still see around 130,000 casualties on our roads each year. Design of our environments can really shape the risks for road users, with evidence of an 88% reduction in near misses at pilot sites. This example offers a scalable, data-driven way to make roads safer for vulnerable users. The success of this intervention has recently been recognized by the 2025 DfT, Department for Transport, Technology Innovation Award. And I'm really delighted to be joined by the innovators who delivered this fantastic example of practical AI. Firstly, we have Nicholson, CEO and co-founder of VivaCity. In the 10 years since founding, Mark has grown VivaCity to support more than 170 local authorities across 7 countries, helping them build smarter, safer, and more sustainable cities using high-quality AI-powered transport data. I'm particularly excited as the Academy's Enterprise Hub has supported VivaCity's journey. We're also joined by Anushka Fernando, VivaCity's senior research engineer, who develops computer vision algorithms for traffic signal control to make roads safer. Anushka is experienced across a broad range of statistics, machine learning, neural networks, computer vision, and deep learning. And for the adoption perspective, we have Callum Bick, a senior research analyst at the West Midlands Combined Authority, who applies his road safety expertise to statistical analysis to help develop evidence-based recommendations for transport decision-making. Callum's work drives a bunch of projects that enhance road safety to enable targeted interventions that reduce risk and improve network performance. So after this intro, we'll get started on questions in a minute, but before I get the ball rolling, we'd love to hear from you first. So please join our Slido by scanning the QR code or going to the website and entering the code displayed in the chat. And the question is, how confident are you about using AI? So I'm going to pause for a moment just to see if the results flood in, and then we'll get started with the conversation. Give it a minute. Well, we've got a somewhat, that's good. Okay, well, I'll let the comments come back in on that, and let's get started on the conversation. Callum, I'd like to go to you first. Can you tell us about the challenge you were experiencing in the West Midlands and how you thought about trying to address that, particularly thinking about consultation with the public? Where did you start? What was the process?
Absolutely. So it was kind of the first stage was in consultation with residents, communities, and businesses, and a couple of key themes kind of emerged very early on. And the first of them being people didn't feel safe enough to kind of walk around anymore on roads and pavements. They felt they were too unsafe, and this was backed up by the data as well, with almost a third of our fatalities being pedestrians on the road. Equally, cyclists felt that there wasn't enough segregated infrastructure for them. The drivers didn't give them enough room, but unfortunately at the point we didn't have enough data to kind of back this up. We didn't have any kind of evidence to kind of go along with this. So we wanted to look at something different really that could provide us this. And this wasn't just kind of where collisions had occurred. It's more about identifying locations which had adequate footfall, cyclist journeys, so that we could kind of implement something that we'd know we'd try and track risk exposure for vulnerable road users. For a long time within road safety, it's been very reactive, where at points you almost have to wait for a collision to occur before you can make any kind of changes or interventions on a road or junction. Now, we felt this wasn't right. We owe more to the residents of our region than just to do this. So we looked at kind of a proactive approach to this, kind of trying to identify where a collision could happen before it happens, and therefore prevent it from happening in the first place.
That's amazing. Mark, can I come to you? How did you then get involved, and how did you work collaboratively to address the challenges that Callum has outlined? How were you thinking about it? And I know you've worked with a bunch of other councils. So the Transport for West Midlands was an early adopter. But talk me through what thinking you went through.
So we were hearing about this challenge not just from Callum and TFWM, but from authorities all over the country and indeed all over the world. I think it's safety has been such a critical part of trying to promote cycling and to improve the road infrastructure more broadly. And that we're hearing lots of people have this issue around, I only have reactive data, I'm reacting years after collisions have happened. And so we started to bring together some of this insight from lots of authorities saying there is an issue here, along with some of the existing tech that we had, where we've been working on computer vision to gather data on what's happening on the roads for a good couple of years by this point. We'd had relationships with a lot of these authorities. We were starting to see these common challenges emerge across lots of different teams at a similar time as people were starting to explore safety challenge much more urgently. This was when we started to speak about Vision Zero on the roads and say we can't be in a world where we're killing thousands of people on the roads every year. And so authorities were responding to this challenge, and we were bringing different authorities together to explore that, looking at focus groups, looking at collaboration sessions, trying to release prototypes into the wild and get really early feedback. And it needed that feedback. There are a lot of early challenges. You can imagine trying to identify a near miss between a bike and a car, and AI sees a bike in a bike rack on the back of a car. They're very close together. And so that is a challenge and something that clearly we need to persuade the AI not to flag. And so a lot of early issues when we started to release technology to local authorities, which we needed to work really collaboratively to address.
And how did you deal with questions of privacy at that point in the conversation? Obviously, you're dealing with a whole lot of information about the public.
Yeah, sure. So as a company, privacy has always been really important to us. We put out cameras with onboard computer vision instant recognition capabilities. Crucially, each of those cameras is acting more as a sensor than a camera. It's not sharing the video data back. It's sharing anonymized data about what's happening on the roads. So in the vast majority of cases, our sensors are just sending back 1 byte, 2 byte, 3 byte, rather than the videos. For the near miss product, that became more challenging. We're trying to identify safety issues on the road and really understand those. You need to see what happened. And that's such a compelling way to persuade people there's an issue that needs to be addressed. But you need to do that in a way that's privacy conscious. And so we looked at different blur levels and making sure that the videos that we sent back, you could see what happened, but you can't identify anyone. No number plates, no faces, nothing that can go back to individuals. So it's all about finding that balance of how do you get the insight you need without invading privacy.
Well, that's a really good segue actually for me to go to Anushka now, because I'm now starting to get really interested in technically what you did. So Anushka, it'd be lovely to come to you, and would be really good to get some view on from a technical side. How did you embed these kind of considerations in the design? So yeah, I mean, I'm interested in what techniques were you using? What were the sort of key elements of the AI? How did you manage the data? How did you deal with scalability? Because it's a lot of data, and so on.
Yeah, I think there were some clear phases to the delivery. And I think the first point was we began with workshops to define the problem space with TFWM. And these were in-person workshops with product team members. We had multiple phone calls because we had presentations to constituent boroughs as well. So we really had in-person technical expertise to work with TFWM to try and find the right solution to their problem. And we also wanted to educate them on what our CV can and can't do as well, so that we could get to a point where we could see what we could get from these data to action. So TFWM already had 250 VivaCity sensors deployed with smart traffic monitoring. So they had counts and tracks data in their estate. So we added 40 more road safety licenses. So that means they could now extract speed and near miss at these sites. And we worked with them to decide which sites were appropriate. We have a lot of experience in understanding what makes a good site in terms of where the sensor location is, what the view field is, what could be obstructing. So we really worked with them to find the right sites to roll out this product. And then once we had decided on how we were going to go through this, we then started by providing them with one video sampled every hour. So this is a high definition video, but it provided technical limitations on how they could store it. And speaking to TFWM, it became apparent that they needed more data. They wanted to do a before and after analysis, and one video an hour was not enough. So we switched to capturing all near-miss videos and switched to low-resolution videos with blurring for data privacy. But then that posed the next problem of there being a lot of videos for them to review. So how do we handle so many videos? So we then worked to improve the precision on our near-miss interactions. So we have interactions between pedestrians and vehicle. So we did some in-house work on our models. We have multiple models that are underlying this product. And we also worked with the client to optimize some parameters that are available on the dashboard so that they were seeing less videos that were more relevant to what they deem to be a near miss. Because this product provides a wide range of unbiased interactions, which are based on a set of thresholds. And that was intentional because we want to be able to generalize this product to other councils. But we want to give the tools to the customer to then optimize this product to what they deem is a near miss event. And then we worked further along trying to improve the filtering of these videos. So we split out vulnerable road user speed from non-vulnerable road user speed. We added extra filtering ability, removed stationary vehicles from the interactions, and we just helped the customers get to more relevant interactions faster. And then we got to a point where both TFWM and VivaCity felt we were at a point where we could roll out this technology, which resulted in this wonderful real-world case study.
Fantastic. And you talked a little about the underlying models there. It'd be really useful to understand what they are. What are they based on? What techniques are you using? I guess for many people in the world, they think of a model as ChatGPT doing generative AI. And of course, there's a whole lot more subtlety to it.
Yeah, so we have a camera which feeds into a video stream. And for every frame we take, it's at 15 frames per second. We run an object detection model. So it's a model that detects objects within the scene, so cars, pedestrians. We then buffer some frames together, and we have what's called a tracker. And we actually have a 2-pass tracker. But basically, it's tracking the movement of the object across these frames. And it gives you a track ID and also a track pattern as well. Then on top of that, we also have something called 3D Pose, which we actually in-house were working on, but then this gave us a real use case to optimize it further. And what that does is that gives you the orientation of the object and its positioning in the road. And what we did was we optimized the 3D Pose, so it puts a footprint on the road, and then we transformed that footprint into real-world coordinates. So then we could see how close two objects were to each other in real-world coordinates, because that becomes part of how we determine if something is, well, it's one of the indicators we use to determine whether something is a near miss, is how close they are to each other.
That's really interesting. Thank you. Callum, could I come back to you just to bring it back to you and go, like, when we started rolling this out, obviously it then needs to map onto reality, and in particular the sort of concrete challenges you were trying to address. What problems did it throw up at this point? How did you manage those?
Yeah, so I think with projects like this being so innovative, kind of mistakes are always going to be made early on. And I think from our side, I think we kind of cast the net out too wide early on. We tried to bite off a bit more than we can chew. As Anushka said, we had 40 sensors on the network, and some of these were pulling in hundreds of records each month that we just didn't have time to kind of go through, validate, understand what had happened there. I think at the time we had a road safety team of one person, so we just didn't have the resources at this point. And I think there's also, as it was early on, as kind of the model was changing over time, there was some false positives we found. There was some that we'd watch a video and we wouldn't, as Mark touched on with the kind of bike rack on the back of a car, there wouldn't be any risk factor associated to that in our view. So we wanted to look to narrow down what we were looking at and try and focus our time and resource on kind of the most risky kind of incidents on the network to kind of make best use out of our time, really. So it was a slow kind of work in progress at the kind of early stages, and we didn't really get the insights straight away that we were looking for.
And how long did that process take before you felt like you were circling in on something that was really, really, accurate and giving you insight that you could use?
I think it was probably a good 6 months or so. I think the kind of tech within the VivaCity sensors was evolving and it was improving. And then, as Anushka touched on, there was different kind of parameters they introduced to allow us to focus down our search and make sure we're focusing on the right sort of records and kind of ignoring ones that we didn't feel had any risk exposure to.
Yeah.
So then from there, we kind of worked through that to get to kind of that better kind of resource management.
And Mark, what was that like from your point of view? You were obviously working collaboratively with WMCA there. How did that process work out? And, how long did that take in your mind?
Yeah, I think it was about, it took a while to get to a point where the technology really works. We're still developing it. There's still ongoing things that we want to keep improving. And as Callum outlined, the early challenge was primarily it gave so many videos that you actually need to work out how do you collapse that down to a manageable set without killing the ones that you're interested in. And so lots of energy going into adding filtering, improving detection of false positives in order to make that all work. There's some discussion with academics en route to understand are there other pieces out there in the ecosystem. I think what we discovered is that there wasn't much work that had been done on this yet, because computer vision technology's only just got to the point where it can do this. And so we were trying to push out that cutting edge of technology, which is an exciting place to be, but it's one where there's always going to be lots of back and forth. And the only way to progress that further is to work closely with clients who are using the product and respond quickly to the feedback. So I think, lots of time looking at all those videos, helping clients to sift through them, working out how can we improve that sifting process and narrow down to the ones that are truly interesting.
I'm interested in this from a technical point of view. Maybe I can come back to Anushka, because we know that, as I said right at the beginning, AI isn't always reliable, and you've talked about false positives there. How do you think about that technically? How do you feed that back into the algorithms and the model? So it sounds like there was a fairly manual process where you were all sitting down together, applying through a whole lot of videos and working out which weren't working. But is there, how does that feedback technically? How do you deal with the downside risk cases?
Yeah, I think so high quality computer vision is essential to all of our products. So our object detection model, how accurate that is, then is sort of the basis for all of the other products we have. So we're continually improving it. Every sensor we release, we can, which is a wonderful thing about our sensors, we can actually capture images. So we capture our own data consistently. And all of that data is just constantly being fed into our model. It gets labeled with the right annotations, and then it gets fed into our model. We train on it. So we're constantly updating our model and improving parameters. So I think from the computer vision part, it's something that we're constantly optimizing, and we have test sets, so sets of images that reflect real world issues that we have, such as we have a test set for glare, so images that have lots of glare in, and we're trying to improve our object detection under glare, which obviously can impinge how accurate it can be at detecting pedestrians, for example. But then I do not want to negate the importance of human in the loop with all of these, great big AI models that are coming out, and human in the loop is so important to get real world value. So working with the client and understanding what they deem to be a near miss and what they see as a severe interaction is really the way that we make sure that our AI is doing what it's supposed to do. We also have internally validated videos ourselves and created a test set. So videos where we say this is a true positive, this is a false positive, false negative, and then try and optimize some of the parameters. But it really is about working with the client to understand what they deem to be a near miss.
Okay. I just add to that, I think for me, one of the really critical points in all AI development is the iterative process, and the fact that you just need to keep going and keep improving it. You keep finding edge cases the longer that you use the product. This is true of any software product or any tech product, but I think it's particularly true of AI when it's all probabilistic and you're in the real world and you're sort of interfacing these models that you've trained in a sort of almost academic vacuum with the real world. And then things happen, things change, and you identify the bikes on the back of bike racks that are not a real near miss. So I think it's about that iterative process that keeps going through the life of the product and will keep going for a very long time, as we're seeing with ChatGPT. Early versions of ChatGPT were not as good as the current versions. All AI improves, even when they're sort of different branches of the field.
Yeah, and I think this point around human in the loop is a really important one, because there's so much talk at the moment of autonomous agents, and everybody's driving as hard as possible to create as much autonomous AI as possible. And the big thing that worries me is that's fine, but what happens when there is a failure, and particularly when that agent is integrated into something which is mission critical. So I think we have to think very, very carefully about the trigger points for how humans actually get activated to deal with the failures. And this is a very good example. This actually brings me back now to Callum, I think, and Mark as well. So you got more and more confident over time. You're getting trust and legitimacy. So I'm now interested in then what happened. So how did you go to the councils to get them to act on the insights? What happened? So how did this improve the lives of ordinary people? What did you do with it?
Absolutely. So once we started reducing the numbers of records we were looking at and videos we were watching, we introduced a kind of internal validation stage on our side where we'd kind of go through the video and kind of attach it to the metadata, and then join things like kind of how we kind of gave it a scale of severity. And then we also looked at kind of grouping it into kind of thematic groups to explain what's happening there. So if we could try and build up a picture of what was happening at each junction. I think from there, we looked towards kind of the ones we had the clearest idea of what was happening. We understood what was happening, and then how kind of the risk exposure at that junction. So to kind of sell this to kind of the councils and local authorities, we knew we needed kind of a test case, a use case scenario that we can prove has worked and kind of has actionable difference on kind of the residents of our region. So the kind of use case we found was in Coventry, and it was kind of a wide bell junction with a really long kind of crossing for the pedestrians and very little kind of pavement for them to do so. So we had several meetings with engineers at Coventry City Council speaking about what joint action we could do on this road layout to change it. So we ended up narrowing the kind of the mouth of the junction, introducing a central reservation and extending the pavement a little bit longer. This was in aim to stop cars really just, when the junction was so wide, they're able to just really just go around without braking and kind of attack the junction if anything. So we introduced this measure to kind of make people reduce speed up to the junction, and then also give kind of some central reservation for pedestrians and vulnerable road users to kind of take relief when people are crossing and they're not given right of way. This was really useful. This produced a statistically significant decrease in validated near misses at this location. As you mentioned earlier, it was 88% decrease in validated near misses. So this is near misses once we had kind of gone through our checks and kind of scaled them on how severe we think they are.
And is that being rolled out? So how many other places practically would you say it's being rolled out at the moment, based on the data?
So we've got kind of patterns and ideas of what we want to do next. It's just kind of acting on that. We've kind of used Coventry as our test case. So now we're trying to show people the results of that and show how well it can work when we're using this data alongside kind of real life interventions to make difference.
Very good. I guess that brings me back to Mark, because I'm interested in now. So we have this like really interesting test case, really interesting data. How do you think about scaling this? So how will it scale locally, nationally, and obviously you're also working internationally? Where are you deploying it elsewhere? What are the most common challenges to adoption and so on?
So I think for us, the critical thing for clients to be able to get value from this and for a community to get value from this is you can't blanket everywhere with these sensors. You can't cover a whole region the size of the West Midlands with them. We're talking about having 40 sensors with near miss in that area, but that is a huge area with 3 million population. So for a lot of our clients, this is about really targeted interventions and looking at where are we worried about? Where are the areas of interest right now? And how can we gather more data to justify an intervention or to justify leaving it be, to plan that intervention in more detail? So a lot of our conversations with clients are, what are the safety challenges that you're experiencing right now? How can we help you to explore those and to diagnose those in more detail so that we understand, okay, there were 3 fatalities at this junction in the last 5 years. But actually what is happening day to day at that junction, and to really get under the skin of it so that they can do the redesign. And we're now seeing that kind of capability be rolled out all over the world, from quite a few in the UK. We've got now some 20, 30 odd authorities using the road safety capabilities, all the way out to New Zealand, where we ran quite a large study looking across 5 different cities at different safety challenges in different areas. And so from this sort of early work with the West Midlands, this product is now going to cities around the world and helping them to solve these very specific challenges. What we're excited about next is how do we help them to scale that up. We touched briefly on 40 near-miss sensors here, but a sensor estate of 300. How can we rotate things around and give much more visibility across the whole city based on all the other sensors as well? So I think there's much more to come here, but for now, we're already, as I say, in quite a few cities around the world.
And I guess this is a question for both you and Callum. I'm interested in how the stakeholders in the West Midlands reacted. So what were the conversations like at the local councils? Were people convinced? How much technophobia did you have to get over? What were the kind of conversations like that?
I think it was difficult early on. I think especially kind of where the tech was at that point, when we were trying to demo this kind of software to kind of other kind of partners, local authorities, people would see the kind of false positives, the kind of low risk interactions quite frequently. So confidence was really kind of hard to buy at that point, and we knew we had to do something ourselves to kind of get that buy-in from the wider partners, as the confidence wasn't there early doors, but as we as the project grew, and I think with the introduction of the parameters so we can filter what videos we're looking at, I think also their detection software has improved. So the confidence has grown as the project's evolved, really.
And do you think sorry, go on, Mark.
I was just going to add to that. I think as the technology's improved, we've been able to extract out more compelling videos that sort of, I think for policymakers and for councillors, being able to show a video of this near miss happened and here's another very similar one at the same junction. Seeing it in the real world, it's very hard to deny once you see one of these just 10-second clips of something which makes you go, and you're drawing your breath in, then you have that emotional response as well as the logical response that means it's much easier to get decisions through.
And have you had any response from the public? How do people feel about it? Do you think there's been a response where people have been worrying about privacy because there's sensors, or do you think they're actually looking at this going, this is really good because I'm not going to get run over?
So we haven't I personally haven't received anything around the privacy point of view. I think it's been largely positive. I think it's allowed us to kind of react to kind of public consultations and their opinions better. We're allowed, as we have so many kind of sensors on the network, and we're able to move these kind of near miss licenses around. It allows us to kind of respond to their kind of worries and claims quite quickly, so that they are being listened to, and we're trying to make any kind of actionable difference that we can quite quickly.
Yeah.
Well, just to add to that from our side, on the privacy piece, every sensor that goes up has a sticker put next to it to say this is a VivaCity sensor and it's gathering anonymous data for these reasons. Please contact us if you want to know more. And we get an email on that maybe once a week, once every 2 weeks. But the overwhelming response when we go back and say there is no personal data being collected, this is all about anonymized data to improve your road network. Members of the public are really happy with that, even the ones who are bothering to email a data protection email address. So I think we're generally seeing a really positive response to that privacy approach, and making sure that we are finding that balance of gathering the data but protecting personal privacy.
Very good. So now we're talking scale. There's obviously scale in the West Midlands, the partnership growing, hopefully more sensors. Callum, I'll come to you first, just how you're thinking about that scaling. And then I do want to go to Anushka. So just to get a sense from her technically, as you grow and you scale and you have to deal with more of these different kinds of inputs, what happens to the product? So maybe Callum first.
Yeah, so I think 40 sensors, I think we've still got a very small road safety team, really. So 40 sensors feels about right for us at the time being. We've still got a 30-month contract with VivaCity to kind of keep continuing this work and pushing forward. So I think for us, it's how do we move sensors around once we understand what's happening at each junction? How long do we need to take to understand fully what's happened? Do we need to keep the sensors there for a certain amount of time? And then how long can we move them? And I think also, a really big piece of work I'd like to look at is kind of how can we take that data from available sensor locations and how can they map out across other similar junctions with similar traffic and road characteristics, and how would an intervention work at one place compared to another? And if we could look further, as Mark touched on, we can't have a sensor on every junction. So how can we take what we're learning from these 40 sensors to apply to the wider network?
Yeah, very good. Anushka, can I come to you? I'm interested in your take on all of that. What does that do to the product? What are you working on at the moment that will allow you to scale it on the level that Mark and Callum are talking about?
Yeah, I think, I guess as I mentioned before, the product does contain lots of unbiased interactions, which allows us to mold to whichever client and the interactions that they're interested in, because they can then refine the product themselves. But as we roll out sensors and sensors are installed in new locations, we're immediately capturing data from those sensors. So we're seeing the field of view and we're capturing images, and we use that data immediately to start training models. As we see use cases from specific clients for, say, wheelchairs or e-scooters, for example, we can start triggering when we see those enter the field of view. So we get images to then train our models on. So it's, as Mark said, it's an iterative process, but one that we're is almost a well-trodden one as we are expanding and scaling, and as our sensors get installed, we're immediately acquiring data to then train models on.
And are you consistently changing or improving the underlying models, or is it just a retraining point?
It's a mixture. So for example, the 3D pose model, we were already starting to work with this, but then it was really accelerated due to the use case of near miss and adapting it so that the footprint was as accurate as possible so that we could look at those near miss interactions. So we have a number of threads happening in parallel, and as use cases come through, we try and optimize and prioritize.
Very good. I want to go to something about inclusion. I think many of you know, the Academy is committed to a top-level target of technology improving lives, and we obviously have a strong focus on diversity and inclusion. How is this going to improve and create a more inclusive transport system? Can you use the AI to make public transport safer, more accessible for those who don't have access to their personal transport, or who might be in a wheelchair, or might be a cyclist, and so on? So maybe I'm going to all of you actually, but maybe Mark first, because I know you've thought about this.
Sure. So I suppose first thing to say is, if you look back over the last sort of 30, 40 years worth of improvements in safety in the transport ecosystem, most of them have come from the cars, and the cars themselves are now safer to drive, and they crumple in the right ways, they protect the drivers. But the place where we haven't seen the big improvements in safety is on pedestrian and cyclist side. Anyone who's now walking alongside a car that is now bigger and heavier than it ever was before, that's now a more dangerous place to be. And so one of the sort of key premises of this technology was being able to understand not just vehicle-vehicle interactions, but actually vehicle-cyclist, cyclist-pedestrian, all the other sort of interfaces between different types of road user. So at a sort of fundamental level, making sure that we can give that data to the local authority to be able to make the changes, like the case study here of narrowing the mouth of a junction so that pedestrians have a shorter distance to cross, so that cars are going more slowly. I think all of that really drives that inclusivity agenda. I think the other piece to touch on here is that from the point of view of thinking about wheelchairs and different kinds of pedestrians that might move at different speeds, that is something that the road ecosystem is not currently very well adapted for. It currently assumes a particular rate of crossing, for example, at a pedestrian crossing. And I think over time, technology like this that shows, well, actually, that pedestrian crossing that is only red for 10 seconds, but a wheelchair user might take 15 seconds to get across, and then suddenly cars are beeping at them or driving at them. That's the kind of scenario that we want to be able to capture and demonstrate and provide back to authorities. So I think data is the solution in this case to making sure that we can design that inclusive transport network.
Callum, is there anything you wanted to add to that from the local council point of view?
I think Mark's answered it really well. This software is focusing on the most vulnerable of our transport users. It's the cyclists, it's the pedestrians. I think at Coventry, some of the really scary near misses we were seeing are cars whizzing right behind a mother with a pushchair. So these are the most vulnerable people that could be on the road, and we're seeing really kind of dangerous and risky kind of maneuvers happening on the road. So that's kind of a real push to why we've kind of intervened at this location to make it safer. And judging by the videos we're seeing afterwards, we're not seeing that as much. We're seeing pedestrians or a woman with a pushchair, a mother, stop at the central reservation so the car can pass and then they can cross in their own time, which is really helpful.
Fantastic. Well, that's been a really interesting conversation, certainly for me. We've actually got a pile of questions that have come in. So what I want to do now is work my way through some of those and see whether we can get through at least a proportion of them before we end. The first question I think is an interesting one. So I know there's lots of conversations at the moment. This is a question from Syed Hassan around digital twins. So I know there's lots of talk in different local authorities around how we build digital twin frameworks for transport infrastructure. I don't know if there's one actually running in the West Midlands, but Callum, maybe you can answer this first and then go to Mark. Are we taking this data, building it into a broader digital twin framework? Can you synchronize the data with physical and digital assets that are already out there? How does that work?
So we are in the kind of the project of building a digital twin in the West Midlands. It's in its infancy at the moment, but we are getting there. I don't have loads of kind of expertise in this field. I'm not one personally working on it, but I think we're looking to build in the VivaCity data, but there's been no discussions as such on bringing the near miss data in. It's probably worth a discussion on how we do that, but to my knowledge, we're not looking at bringing the near miss in just yet.
Mark, anything to add from your side? Is this happening anywhere else, or in any of the other deployments? Do you have big digital twins where this particular data gets built in and integrated with other data sets?
Yeah, I think with digital twins, they're such a huge technology investment to make a digital version of a city. You need to be really careful with what you're using it for, and make sure you don't get sprawl of just kind of trying to cover every single possible data set. And I think the times that we've seen digital twins be most effective is where they're narrowly defined and they have a really clear common sort of objective. And I think the safety piece is probably a bit further down the line of sort of the evolution of those data sets. I think the starting point for digital twins in the transport space is mostly around real-time modeling. It's around understanding what's happening with signals, how do we forecast half an hour or an hour into the future and reduce congestion because we understand what the road network's going to do next. And that is much less about safety and much more about just congestion, counts of vehicles, speeds of vehicles across the network, and modeling that through. I think the safety piece is an excellent addition, but I think that's the next phase. And that then feeds into how do you do long-term planning of signals and of city networks. There are some projects in the US which are looking at V2X communication, so that's vehicle to anything. In this case, it's looking at trying to get the junction to communicate to a vehicle when it sees a safety issue. So a pedestrian is starting to cross and it sends an alert to all nearby vehicles saying, watch out for the pedestrian. And the vehicle that might have its line of sight obstructed by a van already knows that that pedestrian is there. That kind of concept, I think, is really exciting. It's not quite a digital twin, but it's providing some of that real world data back into the digital environment and making sure it can be picked up digitally. But that is all quite a hard ecosystem to crack. You need to get both sides, both the vehicles and the infrastructure, to be talking to each other to make all that work. So I think we're probably still 5-10 years away from that being a scaled reality.
That's a very good link, actually. Another question that came through, this is from Mihai Kalip, where he asks, are the AI models operating purely as detection systems for near-miss events, or do they include any predictive or causal components that can anticipate collisions before they occur? You kind of touched on that in one use case. Is there anything else that you and Anushka are thinking about there?
Yeah, I think just to clarify, so yeah, we do have an object detection model that detects the objects within a scene. We then track those objects. We then look at the footprint on the road and look how close they are. But all of these data actually feed into 3 engines. One of these is the time to collision, which is the time remaining before 2 objects will collide if course and speed are maintained. So that's one way of looking at the time to a potential collision. We don't actually separate collisions and near misses in our data set, but we do have this engine as one of our ways of detecting near miss events.
And so I think,
go ahead, Mark.
I was just going to say the question then is, how do you use that data most effectively? So far, we've been using that primarily to generate videos and data for people like Callum to support the planning of the infrastructure. I think the sort of next stage would then be, how do you get that to the real world to provide real-time sort of time to collision data and to flag that to vehicles? As we get to autonomous vehicles, I know Waymo are doing some work in London in the near future. Wave are already here in London. So I think there's a lot to explore around the autonomous vehicle space and how that then interfaces with the infrastructure.
Well, yes, and Alex Kendall from Wave was also part of the Enterprise Hub, so hopefully you can have a conversation with him at some point. That would be very, very helpful. I do have another question from Miha, which I think is interesting technically, and that is, at the moment, I think the sensors are purely vision-based, right, cameras. Are you thinking about integrating other modalities such as radar, LiDAR, acoustic sensing, anything else to improve the data or the robustness?
Yeah, I think that definitely is something to work with, I guess, the local authorities to understand what's available within the sites. But to say that our data has very high availability, it's very rich, it has a lot of information and very good tracking information. So there is an element of the data that we get. We're also aware of the limitations and how to adjust for real world eventualities like occlusion and foliage. So at least the data that we're getting from the actual cameras themselves, we've got real understanding of how to handle that data and how to surface these near miss events.
And I think to build on that, as you add in other data feeds, the sensor gets much more expensive, right? The whole system becomes more expensive. And there's been this trade-off in the autonomous vehicle world of the relatively cheap Tesla systems, which are all camera-based, versus the much more expensive bespoke systems. I think that it's important to consider sensor breadth when you're looking at a real-time safety critical application. The AI needs to make a decision in half a second of, is this the right thing to do? When we're looking at post events like this, and Callum, I'd be interested in your perspective here, but my guess would be that it would be better to have a system that is right 70-80% of the time. It gives you some false positives, but that you can roll out at twice the number of locations versus something that is much narrower but more accurate. I think that's the trade-off that we have to consider here.
Yeah, very interesting question. Callum, let's I'll bring that back to you.
Yeah, absolutely. Kind of, we want to know as much about our region as possible. We want to know as many locations as possible. I think if kind of these sensors would double the price, it would be a much harder kind of sell to other people, and kind of other councils being kind of that much more expensive. I think we were able to do it because we had a lot of VivaCity sensors kind of on our network anyway. So it was kind of a bolt on that we were looking to do with near miss. But if we're only able to do it at 2 sensors instead of the 10 originally, it would be a much harder sell.
Yeah, very good. I'm going to go on to another question from Anne Donahue, which I think is a really great question. And that is, what have been the most surprising behavioral insights gained from near-miss data that traditional collision statistics wouldn't have revealed? I don't know if you can answer that question, but I think it's a really good one. So what did we really learn that was completely unexpected?
Yeah, I think it's a very good question. It's one that I haven't thought about too much. I think I expect people to be more risk averse on the road, kind of when they're looking to cross. I think people don't seem to have as much awareness as you'd assume when crossing the road, and you see some of these really dangerous looking kind of near misses, and people don't seem like they're aware of it, and they don't realize how close it is. They might be, oh, that was close, and just carry on by. But when you sit down and watch it, you realize that was really very nearly very serious. So yeah, it's a very good question. And also kind of crossing points people are using at different junctions. People kind of, if they can, they'll always take the shortest route somewhere. So it's got to build into kind of road layout and where crossings are going, because people always take the shortest route, whether that's much safer or not.
To build on that with a specific example, we did some work in a bus station in a major city in the UK. And they've had a fatality at that station in the last year, where a pedestrian had walked out in front of a bus, basically. And so they were really keen to understand safety across this area as part of the redesign process. And they were originally thinking about just the area where the pedestrian themselves died, thinking about that particular place. But we put up a number of near-miss sensors across the site, and they realised that, to Callum's point of pedestrians just crossing wherever is easiest for them, there were people crossing these roads with buses swinging around corners at high speed, and people just walking out without looking all over the place. And frankly, it's a surprise that it's only a single fatality, looking at some of the videos that came from that site. And so I think now they're able to factor all of that into the design process. We don't just provide the near-miss videos, but also the desire lines, so the lines showing where pedestrians were walking and crossing. and that is then fed into the design process. And so I think it's that, to Callum's point, the recklessness that people have in the road environment that is really surprising and eye-opening from a design perspective.
Yeah, very interesting. Another question from Anne, which I also like. If you could redesign the project knowing what you know now, what would you change? So would it be technology? Would it be the partnerships? Would it be the process? What if you're going to do it? If you were going to do it again, what would you do differently?
It's another good question. I'm happy to jump in first. So I think the partnership worked very well. It was very iterative. We had regular meetings. We were very in touch, kind of talking about what we liked, what we didn't like, and equally we were hearing back what was being changed, how they're improving the offering at the time. I think I wish we started kind of our internal validation at an earlier stage, because it led to us going back and trying to understand patterns that had been happening for months that we just hadn't recorded, and we were just kind of saving videos, but we were saying, oh, this is a near miss, but we weren't saying it's a near miss because a car's gone too quickly around a junction and the pedestrian had poor line of sight. So I think that, so then we had a more rich data set to kind of look back on, rather than having to do everything retrospectively and kind of using up more resource to kind of do what we've already done. I think I wish we started smaller as well. I think we were a bit of a deer in the headlights at this first stage, where there's 40 sensors, hundreds of records, and we just didn't know where to look. So I think we needed a more kind of condensed view on that. But
Mark,
yeah,
anything else to add?
there's probably a lot more.
Yeah, I think broadening that point about sort of getting narrow and specific really early on. I think we were working with quite a few different authorities who wanted a number of slightly different use cases. So looking at vehicle versus cyclist, or pedestrian versus vehicle. Actually, the error cases are very different. We mentioned the bike and a bike rack earlier. Another example of an error case would be pedestrian walking out between stopped vehicles, like parked cars. And actually, there's no safety risk there. From a near miss perspective, the pedestrian's within a meter of the car. Oh God, we've got to do something. And so, the AI thinks that there's an issue there, but actually you as a human know there isn't. So we're trying to solve for a lot of these edge cases across several different areas at once. And in retrospect, I think trying to really hone down on one problem at once and making it really narrow. And that, I think, then builds on Callum's point about a narrow set of sensors as well. I think that the narrower you can be, the better.
So I want to come back to the conversation we were just having about scaling a little while back. I'm going to sort of integrate a bunch of questions here. So I'm really interested in how we think about this from a really big, large scale AI adoption for transport safety. So I know this is a difficult question, but how do we think about the technical and organizational challenges limiting that? Are there questions around interoperability? So that's the first part of it. The second part is actually around trust. So how do we deal with ethics and privacy when we are integrating more and more essentially surveillance technology into public spaces? So there's a scale thing there. And then I think there's also a scale thing around skills. So as we roll this out on a broader scale and we're dealing with more and more local councils and more government people, how do we upskill people to really think about the challenge? So I know that's a tough question, but Mark, maybe you can start, because this is something you're obviously thinking about as you go broadly around the world. It's fine to do a pilot. It's been successful, but how do we really roll it out successfully with all of these challenges out there?
Yeah, I think touching on skills first, perhaps. I think the analytics skills that you need to be able to get good value from this data are above the level where we see a lot of people in the broader population. I think we need to build better tools to help people to get the most from this data. Ultimately, transport planners are time poor, and they haven't spent their time learning how to do lots of analysis because they're learning about the transport ecosystem instead. And so I think there is a skills gap, and there's a role for us to play in supporting that, in providing the tooling to simplify and to accelerate that. And I think there is a broader place for thinking about skills as the whole economy becomes more data driven. I think everyone is going to need to upskill more in that direction, and transport planners are one part of that equation. Callum, I'd be interested in your perspectives on that skills piece in particular from an internal authority perspective.
Yeah, so I think the skills thing was a big thing, and it's kind of understanding what we were seeing at different points of the project. So as kind of touched on earlier, it was a very small road safety team. So that was without me included. So I sit within like the data team. So my team is very data savvy, but kind of bringing this out into kind of wider parts of our kind of organization. They don't always have that kind of analytics skills. So it is kind of building them up to that. I think looking back on kind of technical and organizational challenges around kind of AI adoption is kind of a perfect use case of what we saw in this project. We saw initially there's always an expense that people don't want to do for such an innovative project. And then you'll have the challenges as kind of innovation grows and the tech evolves. You've still got that early stage where you won't get as much as you probably want out of a product. And then people seeing false positives, there's always going to be challenges about that because people are seeing kind of data that they don't trust at that point. So kind of trying to get through the early stage and kind of get to the end where we're seeing actionable results now. There's still quite a big gap in there that you kind of have to push this and really be a driving force within the organization. Otherwise it can kind of be left to the side.
Very good. Well, I'm sorry to say we seem to be running out of time. So thank you, everybody. But before we wrap up, we'd love to hear from you again. So for participants, please use the QR code now to or go into the chat to answer a quick question via Slido. And we're interested in knowing, has your thinking on AI adoption been influenced by today's event? So the Slido will be coming up. In the meanwhile, I really wanted to thank you all for a super interesting and stimulating discussion. Thank you for everybody joining us online for your amazing questions, actually, super insightful. If this conversation has sparked your interest, or if you have any further comments about today's event, or you'd like to propose some topics for us to consider, please respond to the survey that has been posted in the chat and will be emailed to you. And we'd love to get your feedback on how we shape and improve future events. And stay tuned, because we're going to have future events in this Practical AI series on our LinkedIn page. Next event will be on Thursday, the 11th of December. It'll again be something very practical. So looking forward to people being engaged. And I also just wanted to say, if anybody's interested, please join our Hinton lecture on the 13th of November. This is one of the showpiece lectures of the year, where we will be hearing from James Manika, Senior Vice President at Google and Alphabet, who leads a whole lot of efforts to drive forward a bunch of AI innovations across Google, Google DeepMind, and Alphabet, with a focus on their potential to, actually impact people in society on a broad scale. So we'd love to see you there. I can't see the Slido. Maybe somebody can show that to me, just see what came back on the Slido. Not coming through. Peter, if you want to show that to me. No, I'm not getting it. I can't see it. So that's not helpful. But anyway, we will take, there we go. So, yep, we've had somewhat of an influence on people's thinking on AI adoption, a lot. And, it's 14% saying a little. That's okay too, because this is a conversation and a journey that we're all on. But at this point, I'm going to draw to a close. I want to thank Callum, Anushka, Mark for really, really interesting conversation. And thank you all for attending, and wish you all the best. Thank you and goodbye.